Thank you for watching our ACS 2022 talk on using Labflow as a platform to accelerate research in laboratory education. Before working with the researchers and educators at Catalyst, my colleague and I were both deeply involved in research projects in chemistry education. My name is DeSutter, and I received my PhD in the learning sciences in the STIFE group at the University of Illinois at Chicago.
My name is Zumalt, and I received my master's in chemistry education from the Raker Group at the University of South Florida.
We'd like to give you a preview of the work we're doing at Catalyst Education to use Labflow as a platform for scalable data collection and how that can integrate into your research.
Lab education is a central part of the science, technology, engineering, and mathematics curriculum because of its focus on getting students to engage with science as a practical discipline. The goals for labs do vary, but there's a core commitment to getting students to get engaged in the process of doing science. The goals that we target vary by course. A general chemistry lab, for example, will have different target goals than a PChem or analytical lab. And certainly the focus of what is an important outcome of a laboratory course shifts even more noticeably as we look across disciplinary boundaries to pedagogic labs in biology or physics. That said, there are a number of normative beliefs that shape what we think matters in lab education. These beliefs shape how we define what progress looks like from day one of lab to the end of the semester. These beliefs span from content learning, such as taking theoretical ideas from lecture and gaining a deeper understanding of them through experience, to scientific, practical, and general skills, such as making observations, taking accurate and precise measurements, as well as working together in teams and having good time management. Studying learning then requires us to use research methods that give us insight into these various skills. Lab researchers have imported a number of methods to do this kind of work, spanning from embedding in a lab course as an ethnographer, to interviews, to more experimental methods like protocol analysis and pre-post intervention. We also frequently are interested in analyzing videos and artifacts from those settings. However, many of these methods require a physical presence in the classroom. The COVID-19 pandemic has also thrown into sharp relief how the assumption that students will all be together in a room is not always viable. Data collection becomes more complicated when individuals and resources are distributed across settings. And we know that even though students may be doing some of their lab work online, learning is still happening. We just may lack a window into what is happening in those learning contexts. I think we should take a page from the learning analytics research community. This community has had a lot of success using high-resolution and multimodal data to gain insight into the learning processes that occur in classroom settings. They frequently use high-frequency, high-resolution data from learning platforms like learning management systems to understand their students. The data from these platforms become for social science like what the microscope was for biology. And the data we draw on as evidence of learning includes things like event logs, clicks, and page durations. However, most learning platforms are not designed specifically for lab education, and adopting them is clunky or lacks certain functionality. The result is that in relying only on traditional data collection, maybe leaving rich sources of data on the table that might open up insight into lab learning. Labflow is a lab learning platform that has been built specifically to handle learning in laboratory settings. This makes it an excellent source of data for education researchers to answer questions about learning in the lab and in hybrid and online settings. This is true whether Labflow becomes the sole source of data in your project or is a complement to your existing data collection. Labflow doesn't replace what you're doing, but rather functions as a tool to provide new data sources that support your research. Rich data streams about instantaneous student behavior can enhance the interviews, video recording, and artifact collection you're already doing. In this presentation, we will showcase a number of types of data that are available in Labflow, including achievement data, student data entry, item response theory metrics like item statistics, and user activity in the system. There's potential to answer research questions that drive your research. You can ask questions about things like the efficacy of an intervention using pre-post achievement data, the acquisition of practical, scientific, and general lab skills, and even administrative questions like are TAs grading fairly? With those research functions in mind, we'd like to briefly introduce Labflow and talk through how it functions as a learning platform for the lab. Then we will show some examples of the types of data that we have generated in Labflow. Labflow is a fully fledged lab learning platform. The main landing page is the course page. Within the course page are logical organizing content blocks that contain all of the materials like technique videos, pre-lab quizzes, and experiment PDFs relevant to a given experiment. Activities can be gated so that they are contingent on completing some preparatory exercise. For example, we might want students to read through an experimental PDF before working through a pre-lab quiz before moving into a report. The core piece of most content blocks is the report. Reports are highly versatile components in Labflow. Any procedure, whether it be from our library or something developed by you or your department, can be adapted into a digital report format that includes robust data collection and analysis. Data collection can be made part of any lab. This is a unique feature of Labflow as a learning platform for the laboratory. Many labs are set up to have students enter data in Labflow as a kind of digital notebook. This centralizes this information for you. Students can collect data on a digital device during lab, but they can also just transfer the data from their paper notebook into the digital report. Data collection can be set up to provide instant feedback to students about lab skill relevant learning objectives, such as using the correct instrument precision when recording data and ensuring the data falls within ranges either defined by the instrument sensitivity or pedagogical considerations. The analytic component of a report also includes a number of prompt types. Some of these prompt types, like the one here on the left, asking for the average mass of 2 trials, can be auto-graded. This is customizable, and the logic for auto-grading spans from simple arithmetic checks using student data as input variables to more sophisticated analysis like fitting a line of best fit and observation-based grading. Freeform items, like essay prompts, can also be included to capture open-ended and conceptual responses.
Now that we've seen the ways that Labflow functions as a learning platform for the lab, we'd like to highlight some of the datasets that we've built from real courses in the system. We will see a number of examples of datasets, but rather than show them in a raw format, I've included images of either some part of the Labflow interface or a visualization that I built of that raw data. I want to give us a sense of the breadth of information that is in the data, but really your research agenda will dictate how this information might benefit your work. One type of data we can export is achievement data. This includes quiz performance by student attempt, and by question. For reports, similarly, we can provide student scores broken down by a number of dimensions. Here we can see data for each student grouped by grader or section. Student scores on reports can also be broken down into subscale measures. One of the views we can provide already in Labflow is student scores on items graded automatically versus those that were graded by a human grader. These graders can be TAs, they can be independent raters, it just depends on your context. We can also work with you to identify what constitutes a score subscale and generate an appropriate dataset. Another way we can present report data is at the item level. In particular, we have started to look at ways of aggregating information about the data that students enter. Here we can see the masses that students entered of whey paper and whey paper plus some oxalic acid across multiple trials. At a base level, this might provide some diagnostics to you about the lab and how it's running. For example, if we looked at the data that students entered in person versus online and saw discrepancies, that might be useful information for us about differences in student learning experiences. We are also interested in the potential for this type of data to inform our understanding of what specific lab skills like measurement look like at a fine-grained level. For those of you who do assessment design and psychometrics, we can also provide some useful item-level statistics like the average points earned, correlation of score of this particular item with overall report score, and discrimination index, among other things. For qualitative items, like open-ended responses, we can also provide you with an export of student responses in a convenient format. One source of data that really drives home the frequency and scale of data in Labflow is student activity data. We log, for example, when students access resources, what resources they access, and for reports and quizzes, when they do things like change answers or move between items. Here's a bird's eye view of student activity across an entire semester in a course in Labflow. Each resource type is color-coded and labeled. We can also include metadata that allows you to group student activity along meaningful dimensions. For example, if we hypothesized that students who do well in the course engaged with materials and resources differently than their peers, we might want to compare things like low versus high performers. This animation shows week-by-week activity from the same course of when high and low performing students accessed resources and worked on quizzes and reports across the semester. Now we'd like to show you just one way that you can bring these disparate data sources from Labflow together to answer a question that relates to a core lab skill. We were curious to know whether we could use these data to see the benefits of good time management. We know we want students to manage their time well, but could we see evidence that this was related to their performance in lab? So we asked the question, does when you start working on lab materials each week translate into increased performance on that lab report? To answer that question, we analyzed 11 weeks of a course and asked whether how far in advance students worked on quizzes, reports, and other resources in the course was related to their final score. We found that the answer to this question was yes. When you start working on a quiz and report matters. You don't want to start quizzes too early, and students who start reports earlier do see benefits on the order of 4.5% per day. Importantly, students who took advantage of time to complete multiple report attempts saw boosts in their score of 15% between attempts. This analysis provides some evidence that time management does translate into improved scores for students. However, we do see that this benefit is tempered by situational factors. As a final note, I'd like to preview some of the big data capability that we have at Labflow and how that may also be of interest to chem ed researchers. Labflow and all of our data operations are in the cloud. We have a few places where we store data. First, we store data in transactional databases that are necessary to run the Labflow application. Second, we recently added in Google BigQuery to our ecosystem. BigQuery is Google's offering for a cloud-based data warehouse where petabytes of data can be stored and queried rapidly. This is where we send data that is of interest but doesn't affect how Labflow runs. BigQuery can merge together multiple sources of data through federated queries. One source of data we use frequently is information from our application databases, like report and quiz scores. BigQuery can be accessed through some public-facing tools for the research community. For example, Google Data Studio is like Tableau and gives you access to click and drag tools for visualizing data. We are also looking to create public-facing datasets for the research community and want to hear from you about what kind of data you'd like to see in such datasets. Ultimately, we want to partner with you to get you access to the data you need in an IRB-compliant manner. The scale of the data makes Labflow a useful tool for answering all kinds of questions that impact lab education. As you can see here, we've successfully used Labflow's big data capabilities to answer some pedagogically relevant questions about student feedback and TA grading practices. Another thing that makes Labflow a useful platform for education research is our robust library of open education resources. This library includes experiments being used by hundreds and in some cases thousands of students across multiple institutional contexts, from large research universities to community colleges. For research questions that require a lot of respondents and high statistical power, the OER library provides a built-in source for large-scale data. Here you can see some of our top adopted reports and the number of student responses we have to date for general chemistry and organic OER experiments. If you're interested and want to learn more about using Labflow in your research, contact us at research@catalystedu.com. To learn more about Labflow, visit catalystedu.com/Labflow.